As far as I can see, that this will be the only location for the battery where it can be installed. All the other locations, they don't make sense here. It is not 100% ideal, but it doesn't actually cover anything. And with these words in mind, welcome back to the off-grid garage here in not so sunny Australia. We have only 45 amps outside. It is cloudy, making 4.7 kilowatts. I'm not complaining, All right, in today's video, we want to keep working on our battery and our PowerWall 2.1 and 2.2. And I think I have made the decision to leave the batteries in this corner here. I can still open the garage door. There is enough clearance around the battery box, and it doesn't cover any devices or any safety equipment here on the PowerWall. I have our solar cable from the pull fence system down here, and probably just going to feed this into the duct and then come down here onto the breaker like this, and that's all done. Yeah, the solar system is completely isolated, it's completely disconnected. There's nothing, it's just a pure cable at the moment. So we are now having a look at the Victron Lynx Peter Distributor, and connecting these cables, you usually break off these little barriers like this, so you can feed one cable, you can feed the positive cable on the top and the negative on the bottom. Obviously you need to start with the bottom one, otherwise you can't reach it anymore. So negative, washer, spring washer, nut. And the manual for the Peter says 14 Newton meters for these connections. There it says 14 Newton meters for tightening the nuts, which seems a lot. No, it's not that much. Okay, then we flip this one down. So in here with the top, we also have to mount our mega fuse at the same time. And because this is just for the solar charge controller with 35 amps, I've got a 50 amp mega fuse here. So we put this one in this location. And here as well, making sure that the ring lug has directly contact to the mega fuse. Then washer, spring washer, nut. Okay, 14 Newton meters. Oh, let me straighten this cable here. So, and this concludes the cabling of our solar circuit. So we've got the incoming solar cable here from the top to the circuit breaker. Then from here it goes down, positive, negative, into the solar charge controller. And this is all done with 4mm cable as it comes from the solar string. And then the output is done with 10mm cable. I mean, not that we need it right now, but this is a 35 amp controller. We may add some more panels down the track, and I want to be prepared and don't want to change the cabling again. So hence I went with a 10mm cable, even it is a bit oversized at the moment, but it is done now. And then we can fully utilize the 35 amps here of this controller if we want to. And this connects then to our Lynx bus bar system, positive here on the top, connecting through a mega fuse to the positive bus bar, and the negative is underneath connecting to the negative bus bar down here. Okay, so we have our charging circuit ready, cable to the bus bar and to the solar panels. And now it's time to connect the battery as well, so we can get some amps into these empty batteries here. As we have discussed in one of the last videos, we want to connect these batteries separately to the power in, to the Lynx Power In. So one battery over here, the next one here, and then we've got space for 2 more batteries. And at the moment I'm a bit unclear how to cable these batteries. So I'm not sure if I connect the batteries and have the cable running underneath the inverter somewhere over there in another duct, and then come up in this area to the power in, or if I should keep this space here for future expansions. I'm sure we will develop more ideas over time, right? I'll do more thinking about this, but for today we just want to connect the batteries as they are, daisy chained, connect them to the system here and see how everything works. So, and that's why I'm going to use these 25mm cables, which came with one of the Mason batteries. Because it's only a 25mm cable, we have to put the appropriate fuse in here, which is 100 amp. I'm just alright with 100 amps because I won't put these cables into a cable duct here. They will just hang here in free air, so I'm having the best cooling ever. And we are not going to use the 100 amps anyway at the moment. This is just temporary cabling now to connect the batteries today, until I figure something out how to tidy this up and make this all workable. And here again, I'll make sure the actual fuse is touching the bus bar here, and also the terminals directly without any washers or spring washers in between. There's no spark. Okay, so what we can see already is the shunt has powered up because it gets power from the battery now, but there's no connection further down to the solar charge controllers yet, to the distributor, because we haven't put in our main fuse here. So the red light means the main fuse has blown, and we just use this 300 amp ANL fuse as our main fuse in the shunt. So there could be a bit of a spark now, because we are then powering up our solar charge controller, and this one has also capacitors inside which charging up then, so there could be a little bit of spark coming up right now. All right, connecting this one on this side. No spark. Okay, and the light turns green because we now have a working fuse installed. All right, and we can also see the blue light is flashing here, so the solar charge controller is now waiting for solar to come in and start the charging process. So before that, we just measure the bus system here. They should give us the full battery power, 52 volts. So I'm just checking the incoming solar for polarity. Yeah, that is positive. There should be nothing down here because the circuit breaker is still off. Perfect. Okay, we click on the pull fence charge controller. It's flashing up there, connecting, and we can see the battery voltage 52.2 volts. No solar incoming. And let's change that. Okay, got 117 volts from the solar panels. It actually could be still turned off. Yep, enable charger. I remember I turned it actually off. So we should now see charging power 27, 40, 50, 100. Do we get 100? It is so cloudy outside, we just had a shower. So 66 watts it is. But we are charging with 1 amp into the batteries now. Yay. So this is all working. I'm not sure if they actually show anything. This one shows 0.6 amps. The top one doesn't show anything, but at least it is charging now. And the solar charge controller is still using the same settings as before. 55.2 volt absorption voltage, 53.6 float, and we absorb for 1 hour to give the balancer time. Not that the balancer is great in the Seplos batteries. So, and what we can do now as well is connect the distributor to the shunt. Not that it makes a difference right now. So, when we come back in here, connect these two and all the lights turn on, and it gives us a green light here and 3 red lights as well, because there are no fuses connected. We just need to be aware that we have 50 volts now here on the bus bars. This whole battery system here is live now, and because I don't want to connect anything else today, I'll just close the covers. Oh yeah, there's 1 power light and no fuses or blown fuses in these 3 locations. And this one has the 50 amp fuse. It is off. And charging with 0.8 amps. It is disappointing. Yeah, see, even our real system does only 1.5 kilowatt at the moment. But still, you know, still. Jeez, but 40 watts, I mean, come on. That is cool, that is good progress. So the next step will be to connect our solar charge controller to the Cerbo GX here. So actually you guys can monitor this system here as well. The SPED calibration center. So let me get a cable here. We still have one in stock. That is a VE Direct 1.8 meter. Exactly what we need. And honestly, we also need to think about the power supply for the Cerbo GX, because as we know, as you may have heard and read in the forums, the Cerbo GX has a problem when connected to 48 volt batteries. Usually you can connect it to like 8 to 70 volts DC, so no problem at all what kind of battery you have. But there was a certain batch they released, and connecting it to a 48 volt battery actually destroys the whole Cerbo. And guess what? Exactly, I have one of these. I checked the serial number and it falls exactly into the range of affected devices. There's a workaround where you can attach a capacitor to the DC input of the Cerbo. Then you can connect it safely to a 48 volt battery. I am honestly not a big fan of that anyway, because, well, if your battery goes down for whatever reason, if you won't have any connection to the Cerbo, you don't have any access to data, nothing anymore. So in case of a fault, the Cerbo will turn off as well. And this is probably the last what you actually want then, because you want this one up and running all the time, so you can have a look at the data and see what was going on. Why did you get a fault? What was the cause of it? So I want to connect this one here either to a different power supply or to a kind of UPS system where we can use a bunch of 18650 cells or something to keep this one up and running until we did all the troubleshooting in case of a fault. So I guess for now we take the Müller battery back and connect it as it was to a 12 volt 200 ampere hour lithium iron phosphate battery, so it could last another 6.5 years until this battery is empty. Magically, the Müller battery exactly fits behind the Mason battery on top of the other Mason battery in this gap. It's the other way around, this way. Haha, the cable is just long enough to fit into the duct and then connects to the Cerbo. Okay, let's turn on the battery, find the magic button. And we should see the Cerbo firing up every second. There it is, it's booting up. Nice. Ooh, 88 watts. Still 0 amps here. Well, this one shows almost 1 amp. I wonder what's going on with this one. I can tell you what's going on here. If I disconnect the big battery here at the bottom, you can see all the power of the solar charge controller goes into the top battery here. And if I reconnect this one, put them back in parallel, it goes to 0, and this one gets all the power there. Classic lithium iron phosphate problem. Same voltage but different state of charge. So obviously the smaller battery has a higher state of charge than the bottom one, and at the moment it doesn't take any energy at this voltage. As soon as the big one is catching up then and the voltage is slightly rising, this one will start charging as well. So there's nothing wrong, it's all good. Just relax, guys, relax. Okay, then let's have a look at the mobile situation at the Victron VRM. We can see this SPAT calibration center down here. Tapping on it. By the way, this is already online for weeks since we installed this PowerWall here. There's a link under all my videos pointing to the SPAT calibration center as well as the big PowerWall and the battery shelf. So we can now see we are live, we are on real time, the battery 51%. I'm not sure where it gets the information from because nothing is connected except the outdoor RUVI tag and the garage RUVI tag. Weather information, no data to display because everything was turned off. But it is online. It is just time to connect the solar charge controller now and get some data into the VRM. And this is just a standard VE direct cable. It has the usual GST plug at the end. And because we are using the Cerbo GX here, we don't need any USB adapters or anything else, just the pure direct VE direct cable. So as you can see, the Cerbo has 3 connections for VE direct. Just plug this in here at the top. So we curl up the cable here because it's far too long for these short distances, and the VE direct port is, oh, it's on this side. Okay, hopefully it's long enough now. Comes through there. And then it connects to our solar charge controller directly. So, and this should not take long until the solar charge controller shows up here in the VRM. Oh, there it is already. Look at this, how quick it is. 120 watts we are charging with. Woo! Data is now coming through from the MPPT charge controller. We can see the solar voltage, the amps and the watts it produces right now. But the battery is still not correct because, well, we haven't connected any Smart Shunt or any BMS to the system yet. So at the moment, it only reads the information from the solar charge controller. And now we can also see the top battery started charging because the voltage has risen just a tiny bit. And now this one is joining in as well now. Well, we still can see here 1.8 amps going into the bottom battery and only 0.8 into the top battery. But remember, we've got the same effect here while charging. The bottom battery will take more energy because it has double the capacity as the top one. So there's always more energy going into the bottom battery than in the top battery here. Okay, so in the last step we only need to connect the battery now to the Cerbo GX to get the right information, the battery temperature as well as the current and charging and discharge voltages. And we are going to use this Victron BMS to the battery BMS CAN type A cable. This is all you need. It doesn't have an adapter. It's just some of these wires are crossed. And this is just another plug and play solution now what we have here. We just plug this into our BMS and to the Cerbo GX and it starts working straight away. Okay, let's do it. So the 2 BMSs of our both batteries here, they are still sitting on RS485 communication. See, this one is battery number 1 and this one is battery number 2. So we take this one off. 1, 2, 3, 4, 5. And put switch number 5 up, which means we have a CAN communication now. Switch number 5 turns on CAN and also tells the BMS, hey, there's another battery connected via RS485. And this battery can stay at number 1. And then you want to connect the cable with the battery BMS CAN type A and to the CAN port of your battery and use the other end, which is labeled Victron VE.Can, to your Cerbo GX. Also, don't forget the CAN termination. There are 2 of these terminators in the box with a Cerbo. And now you could see it. Well, you couldn't see it because I forgot to turn on the screen recording on the mobile phone, but the state of charge jumped now to 17%, and this is the actual reporting through the BMS now. So if we are having a look in the remote console, go into the settings, we can already see we've got a Seplos BMS showing up. And the server already knows about these batteries here because they were connected before. But let's go into the batteries and have a look. And you want to go down to details, because this gives you the details. So we can see battery modules, 2 online, 0 offline, and we can see the maximum cell temperature is in battery number 1 and the minimum cell temperature is in battery number 2, which is our smaller one. So if you haven't seen how to set this up correctly, I made another video. This is the video where I explained everything in all details, how to connect your Seplos batteries and BMSs to the Victron system using the CAN communication. Alright, and here's our PowerWall 2.1 and 2.2. I've just cleaned up the cables a bit here. So I used some Velcro to organize everything, put the lids on the ducts. So this is how the installation could look like. I'm really impressed with the Lynx system, how quick everything went with the installation. And you have also seen the Cerbo GX is a true plug-and-play device. Everything just plugs in and it works straight away out of the box. There's no driver installation, no scripting, no login to a remote console, nothing. It just works. And it's no wonder the Cerbo GX is so popular out there. I wonder why the charge controller is already on absorption. We are at 52 volts. How could it possibly reach 55.2 volt to hit absorption then? What the heck is going on here? Huh. Oh, I forgot the cover. Once again it's raining outside. So I just logged into the pull fence solar charge controller again, and down here it says it is under external control. So in theory it shouldn't matter what kind of settings I put into the solar charge controller now. They are all overridden now by the BMS. And this is now what the Seplos BMS tells the solar charge controller to do. But I'm still not sure why it shows absorption mode instead of bulk. Because with these 2 batteries we are far away from any absorption state. Well, another great benefit of having communication between your battery and your solar charge controllers. It just stops charging in the middle of a sunny day now. What the heck is going on? Okay, here's something interesting. I've just disconnected the CAN cable of the batteries to the Cerbo GX, and the solar charge controller now is in bulk state again. So it pumps as much energy into the battery as possible. But have a look, as soon as I plug in the BMS again, it changes to external control. And then see what the power does. It powers down to 11, 10 watts, 9 watts. What the heck is going on? So obviously the BMS tells the solar charge controller already to slow down. There could be parameters set in the BMS which are not correct yet, so I have to have a look at this. So basically it has turned off our charging altogether now. Here, that's the problem. So the solar charge controller is being told by the BMS to charge only to 52.4 volts. And this is already what we have in the batteries. So that's why there is no power going in. Charge count 25, BMS controlled, yes. It's a slave, external control and BMS. Here, this is for the solar charge controller. That's why it doesn't charge. This is another problem for another video for another day. In today's video, we wanted to finish the PowerWall 2.1 and 2.2. Well, I haven't connected the part of the 2.2 yet, so the inverter, there's no load on this battery. But I want to charge it first and see how everything goes and works. So you can now monitor the SPAT calibration center as well through the Cerbo GX here. I linked this all down below under the video. Okay guys, so far this video from today. Thank you so much for watching. Thanks for all your amazing support here on the channel. And until the next video, when we will find out why this battery is not charging, you definitely stay charged, stay safe, and thanks again for watching. See you then. Bye bye. Oh wow.